Hey friends, happy Tuesday. Let's get started with our bell ringer. Get excited. Today's bell ringer has some different and more challenging questions for you to work on. So we're actually going to start with the rounding question first. We're going to round 251 and 341 thousandths to the nearest 10th place, ones place, and tens place. So let's get started. First, we need to find the digit in the tenths place, which is a 3. Its next door neighbor is a 4. 4 or less, let it rest. These digits need to come along for the ride, and then the 3 is just going to stay put because the 4 is a let it rest digit. And then these two digits just revert to zeros. So you can include them or not. It's up to you. When we add zeros to the end of a number on the right side of a decimal point, see here's the decimal point and these digits are on the right of it, those zeros don't change the value of the number. Of course, that's not the case when we're talking about numbers to the left of the decimal point. We can't just add zeros willy-nilly there because that will change the value of our number dramatically. Next, we're going to round 251 and 341 thousandths to the nearest ones place, or to the nearest whole number. We have a 1 in our ones place, and its next door neighbor is a 3. 4 or less, let it rest. So this number will round to 251. Last, we're going to round 251 and 341 thousandths to the nearest tens place. The digit in the tens place is a 5, and its next door neighbor in the ones place is a 1. 4 or less, let it rest, and 1 is, of course, less than 4. So this one will round to 250. And these zeros, the rest of the digits revert to zeros. Next, we're going to do a subtraction problem. And for this problem, I'm going to show you how to subtract using the traditional US algorithm. For my 7, I'm going to include the decimal point and then several zeros as placeholders. Then I'm going to subtract 4 and 269 thousandths. Obviously, I can't subtract in my ones place, or in my thousandths place, my hundredths place, or my tenths place without borrowing. So I need to start borrowing all the way over in my ones place. This is something that a lot of times kids have difficulty with, and we're going to practice this a lot in the next few weeks. Now that I've done my borrowing, I can go ahead and start subtracting. 10 minus 9 is 1. 9 minus 6 is 3. 9 minus 2 is 7. And 6 minus 4 is 2. So my difference is 2 and 731 thousandths. Next, we're going to do our line plot problem. So when I look at these different fractions, the first thing I want to do is train my brain to pay close attention to the denominator or bottom number. So I have 1 and 2/3, 2/3, 1/4, and 1 and 3/6. When I look at 1 and 3/6, I automatically realize that that's the same as 1 1/2. So that leaves me with thirds, fourths, and either 6 or halves to put on my line plot, which means I'm going to need, of course, some common denominators. I'm going to need to find the least common multiple for thirds, fourths, and 6. So I'm going to skip count by 3s, 3, 6, 9, 12, 15. I usually tell kids, do like the first 5 multiples and see where that gets you. So first 5 multiples for each of these numbers. 4, 8, 12. Oh, and look, I already have my least common multiple. Okay, so I'm going to convert these to 12ths. And after you have a certain amount of practice with this, it gets easier to start kind of doing it in your head too. Get this out of the way. Okay. So I'm going to convert 1 2/3 to 1 and something out of 12. So in order to do that, I'm going to multiply my numerator and my denominator by 4. 3 times 4 gives me 12, which is my common denominator, and 2 times 4 is 8. So 1 8/12 is equivalent to 1 2/3. And then, of course, I automatically know that 2/3 is equivalent to 8/12, so I can leave that one alone. And then when I do 1/4, I'm going to convert that to 12ths by multiplying my denominator and my numerator times 3. And that gives me 3/12. And then 1 3/6 is 1 1/2. Or 1 6/12. I can do that in my head. Okay. So I'm going to do 0, 1, and 2. Okay, I think that will give me 12 equal pieces. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. All right, and then I can just go ahead and plot my values on here. I have 8/12, so let's see. Oh gosh. 1, 2, 3, 4, 5, 6, 7, 8. Oh. And then 1 8/12. 1, 2, 3, 4, 5, 6, 7, 8. Which is the same as 2/3. Okay, put my X there. Can't forget my X. I did that one. I did that one. 3/12. 1, 2, 3. Which is the same as 1/4. 1 3/6, which is the same as 1/2. 1, 2, 3, 4, 5, 6. And that's it. Okay guys, so now that we've done all of that, that leaves us with this question, this measurement question, and this equivalent fraction question for you to do on your own. Okay, happy Tuesday. Let me know if you need any help.